So here, so what we are talking about is okay, I said all these things, right? So I said how to work with this. So I said now next we'll talk about working with one more special function. So there is one more special function is here. So what is that special function you have here is, okay, so there is a function called generators. So what is the name of the function you have? Generators here. What is the name of this function is here? Generators. So what is the use of this generator here? So you can use a generator. Sorry. So you can use a generator, okay, for generating the sequence of values. Okay. So generator is used for generating values. Generating values. Generating. It is used for generating values. So generator function, actually generator function returns. What it will return is generator iterator object. Okay, it will return one generator iterator object. And using this generator iterator object, you can iterate what values generated by generator. For example, see, you can generate the values by using what? Range. Okay, but suppose using range, I can generate the values in increment order as well as decrement order. For example, if I'm saying 1 comma some 11, so this range will generate the values from 1 to 10. Okay, 5, 6, 7, 8, 9, 10. If I'm saying range 10 comma 0 comma minus 1, so this will generate the values from, okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, like this. Okay, so range is used for generating the sequence of values. For example, I want to generate random numbers. I want to generate random numbers. But can you generate the random numbers using range? No. You cannot generate random numbers using what? Range. Using range, I can generate only the values in increment order or in what is that? Decrement order. And not only that, this range, now suppose I want to generate like this, like 1.0, 2.0, 3.0. So it is which range? Float. But using range, is it possible to generate the float range? No. So whatever values you give within the range, these values must be of which type? Integer type. These values, the values what you input inside the range, the values which you input inside the range must be of which type of values? Integer. But is it 1.0, 10.0? These are integers, sir? No. So these are not integers. These are which values? Float. But is it this range is able to generate the values of type float? No. So this gives again error. Okay, then how can I generate? How can I generate the float? Then I have to develop my own function. I have to develop my own function. I have to develop my own function, and that is able to generate a sequence of values. I have to develop my own function and that function is able to generate the sequence of values, right? So what is a generator is? Generator function returns generator iterator object, or you'll say generator is a special function, is a special function here. Okay. So always use this for generating the values, any type of values. For example, I want to generate some 5 passwords. I want to generate some 5 passwords. Which passwords? Random passwords. Then I can write one special function that will generate what? Some values. So what is the definition of Python is? If you see the generator, okay. So this is the definition of generator. So what is a generator? A function which returns generator iterator. Okay, what this function returns? Generator iterator. So it looks like a normal function, except that it contains which expression here? Yield expression. Okay, for producing a series of values usable in for loop. Okay, see, you'll use the values of range in what? For loop. In the same way, the values generated by the generator is used in for loop, or that can be retrieved at a time, okay, with the next function. So that might return what? Next value generated by generator. So this is the Python document definition. But what is generator iterator? Okay, what is generator iterator here is, so an object written or object created by which function? Generator function. An object created by generator function is called a generator iterator. An object created by generator function is called a generator what here? Iterator. See, iterator which allows to read each time one individual values. Okay, yes. So all iterables means all collections are what? Iterators, right? All collections are iterables, and it allows to read individual values. For example, list is there. List is a iterable which allows what? Iteration. Okay, set is a iterable and it allows to what? Iterate it. Okay, so all collections implement which protocol? Iteration protocol, which allows to read what? Individual values, which allows to read individual values, right? So a function which returns a generator iterator, it looks like a normal function, except that it contains yield expression for producing series of value. But how generator function produce or returns the values? Generator function will not return the values using return keyword, but generator function returns the value by using which keyword? Yield keyword. But what yield will do is, now yield is a keyword. So yield keyword. So what yield keyword will do is, okay, so the function which contain yield keyword is called a generator function. Okay, now, so the function, that is how Python differentiate normal function and generator function. The function which contain, okay, which contain yield keyword is called which function? Generator function. The function which contain yield keyword, which contains yield keyword, is called generator function. Yield keyword, okay, yield keyword return. What yield keyword will do? A return value. Generally, a function, how it will return value? By using which keyword? A return keyword. But generator function return value using which keyword? Yield keyword. Okay. Normally a function returns a value using which keyword? Return keyword. But generator function return value using which keyword? Yield keyword. So what yield will do? Return value and pause. After returning value, what will happen? It will pause execution of. It will pause execution of what? Function. After returning value, what will happen? It will pause execution of function. But return keyword after returning value, Will it pause or terminates? Terminates. After returning value terminates the execution of function. But yield keyword after returning value, is it terminates or pause? Pause. So that when you iterate, means when you read next, when you iterate another value, it start from that position again. Okay, it will not terminate because this is iterator, right? It should return how many values? Not one value. Function returns only one value, but generator function returns more than one value. So it should not terminate. It should not terminate. Because of that, it doesn't use which keyword? Return keyword. Return will terminate. Okay, return will terminate, but yield will not terminate. Okay, now so after returning yield keyword, return value and pause execution of function. So when iterate next value it resume back, and continue execution. Continue what here? Execute. Now that is done by which keyword? Yield keyword. Okay. So all functions are not called generator functions. Which function is called as a generator function? The function which contain which keyword? Yield keyword. Okay, if function doesn't have yield keyword, then you don't call that as which function? Generator function. Okay, now, right? Suppose, assume that, okay, it is like a normal function only. Don't think that it is something else. How you write this function? Using same def only. Okay, so def, and this is generate some function name. Okay, so what is the name of the function here? Function one. Okay, function one is the name of the function. So I'm writing yield. I'm writing yield 5. Yield means return. After returning 5, will it terminate the pause? Pause. Okay. Yes. After returning 5, it will pause. And yield, I'll say 9. Okay. So it means now each yield statement generate one value. Okay. Each yield statement generate one value. Okay. So I said 5, 9, 1. Okay. Some 6, any values you can write. So yield, I just write here some 8. Now this function generate how many values? 5 values. Okay, this function one generate how many values here? 5 values. Okay, so how you create a generator iterator? You'll just write f equal to function 1. So when you call the function 1, it doesn't return value, but this is a syntax of creating. This is a syntax of what? Creating. Creating which one? Generator iterator. Okay, like the way how you create a range, you'll say no, some r equal to range. Okay, this is creating which object? Range object. Okay, this is creating which object? Range object. In the same way, you are creating which object? Generator iterator object. Okay, so this f is a name of which object? Generator iterator object. Now this object is given to which loop? For loop. So for value in f is nothing but which object here? Generator iterator. F is nothing but which object? Generator iterator. So what for loop will do? Iterate each value generated by which one? F. What is the first value? It returns 5. So after returning 5, will it terminate? So no. After returning 5, what will happen? Pause. Pause the execution of this, and after returning value it will pause, and then what do you want to do it by using this value? I want to print this value. So after printing value, then next for loop iterate next value. What is the next value? It iterates 9, and then 9 values printed. First it will print 5, then print what here? 9, and then for loop again it will read the next value. And what is the next value here? 1. So it will print a value called 1, and read again next value. Okay, that is yield 6, and this 6 is assigned to what here? Value. And then yield 8. Now this 8 is assigned to which one again? Value. So what is the value generated by this function 1 like 5, 9, 1, 6, and one more is 8. But is it any values to iterate here? No. But how it is returning values each time? By using one keyword called, which one? Yield. By using one keyword called yield. Yield is a keyword. So which you are using it. Now you can see 5, 9, 1, 6, and 8. So how many values generated by this function? 5 values. Okay, now you can customize. What is the meaning of this is, for example, yes. So where it is used in application development, right? Okay, suppose this is yield, which is returning each time one value. For example, I want to create a square series. I want to create which series? Square series. Like I want to generate 1 square and 2 square, 3 square, 4 square, 5 square, and this is up to which one? N square. Okay, I want to generate this series. But is it range? Is it range will generate square series? No. A range will generate either increment order or decrement. So I can write like 1, 2, 3, 4 or 5 like this. -1 to -10 or -10 to like that. But I want to generate which series? Square series. Then what I'm doing, I'm trying to develop my own generator function. Okay, now this is which generator? Square generator. This is which generator here? Square generator. If you want, you can give which value? Start value. You can give the start value, and you can also give which value? Stop value. And you can also give which value? Step value. What is it? These are required arguments or not? Yes. You must give the start value, stop value, as well as step value. Now, is it this is looking like a range or not? Yes. So input the start value, stop value, and step value. Okay, here I'll try to okay, because here square generator always generate the squares of numbers only positive. Okay, so because I'm writing a logic like this. While start is less than which one? Stop. While start is less than stop. Okay. While start is less than stop. Suppose if the start is 1 and stop is 10, I should generate the squares from start to which one? Stop. Okay. So here I'm writing yield. What yield? Start to the power of which one? 2. Start to the power of 2, and then I'm saying start equal to start plus what here? Step. Step is nothing but increment value or not? Yes. So this is generating the squares. If it is start and stop, and step is given as what? Positive. Because I said start is less than what here? Stop. Suppose assume that I want to generate the squares. Okay. So here square generator. What is the start I've given? 1. What is the stop I've given? 5. Okay, or 6, because less than I've taken. Then what is the step I've given? 1. So here it will take the start value as a 1, and stop value as a 6, and then step value as what here? 1. Okay, now is it 1 is less than 6? Yes. Then yield, what is the value of start? What is the value of start here? 1. What is the value of stop here? 6. What is the value of step here? 1. Okay. Yes. So is it 1 is less than 6? Yes. then yield 1 to the power of 2. Means it will return what? 1 to the power of 2. Then start equal to start plus step is nothing but 1 plus 1. What is the start value becomes 2. Is it 2 is less than 5, 6? Yes. Then yield 2 to the power of 2. So generate 2 to the power of 2, which is 4. Then after that, when you iterate another value, then start equal to start plus step. So that is nothing but 2 plus 1 becomes what here? 3. Is it 3 is less than 6? Yes. Then again yield 3 to the power of 2. Then after that, again start equal to start plus step. So the value becomes what here? 4. Is it 4 is less than 6? Yes. Then yield now 4 to the power of 2. Then after that, start equal to start plus step, which is nothing but 5. Is it 5 is less than 6? Yes. Yield 5 to the power of 2. Then start equal to start plus step, which becomes what here? 6. Is it 6 is less than 6? No. 6 is not less than 6. Then what will happen? Stop. Right? Yes. So here it will generate. For example, for value in a square generator and print what I print here? Values. I want to print the values in the same line. Okay. I want to print the values in the same line here, right? So what will happen if you run this? You can see 1 to the power of 2, 2 to the power of 3 to the power and 4 and then what? 5. So is it this is a custom generator or not? Yes. This is customized generator. Customized generator here. Okay, now customized generator means you try to generate, you try to create a range, you try to create a range, and that is able to generate some sequence of values, right? So you are giving a start value and stop value as well as what? Step value. Okay, right. Just to see it. Suppose I want to have a random, okay, random value generator. I want to generate a random values. Okay. So this is a random, okay, random generator. Okay, random generator or random range. So I want to generate number of values. Suppose I said random generator n. N is nothing but suppose if I give the value of n is 5, then it should generate how many random numbers? 5. If I give the value of n is 10, then it should generate how many random numbers? 10. But how I generate these random numbers? For this, I try to import one module. And what is the name of the module? Random. The name of the module is what here? Random. So import. Which module I import? Random module. And then I generate each time one random value. I just write here random dot random integer. There is one function random integer. Okay. So I should generate a random integer from given value from A to what? B. I should generate one random value from A to B. So here I have to input which value? A value as well as B value as well as what? N. From A to B you want to generate how many? Random numbers. From A to B you want to generate how many random numbers, right? So here I'll say A comma value equal to A comma B. Okay, but this should be generated how many while or I can use while n is greater than which one? 0. While n is greater than 0. Suppose if the value of n is 5, it should generate how many random numbers? 5. From A to B, it should generate how many random numbers? 5. If the value of n is 10, from A to B should generate how many random numbers? 10. Okay. So n is greater than 0. Okay. Suppose if the value of n is 5, is it 5 is greater than 0? Yes. It will generate one random number from A to B. After that, I just decrement the value of n by saying n equal to n minus 1. So then next it will become what? 4. 4 is greater than 0. Then generate one random number from A to B. Then n equal to n minus 1, it will become 2 or 3. 3 is greater than 0. Yes. But after generating random number, it should return it or not. Yes. But how this generator function return value? By using the keyword called which one? Yield. What yield here? Value. Yield value. Okay. Suppose assume that I want to generate r equal to random random generator. Suppose I want to generate some values from 10 to 20. I want to generate random numbers from 10 to 20. How many random numbers I want to generate? 5. I want to generate 5 numbers. Okay, 5 random numbers from 1 to 10 to 20, right? Then I iterate each random number by saying for value in which one? R, and then print value, right? Just to see here. So this might be applications where you may go for random. Now 14, 13, 19, 14, and what is that? 11. So how many random numbers it is generated? 5. If I'm saying suppose from 10 to 20, I want to generate some 20 random numbers. Okay, then if I say 20, now it is generated how many random numbers? 20 random numbers from 10 to 20. Okay, now this is generating a sequence of numbers or random numbers? Random numbers. But for that, I created my own iterator. And what is that iterator generator function? Random generator. But random generator is using which function for generating random numbers? Random integer, where you give the start value and where you give what? Stop value. So start is A and stop is what here? B, right? And then after generating one number, you are trying to return that value by using which keyword? Yield keyword. You are returning that value by using which keyword? Yield keyword you are using it. Okay, right. So you can generate, you can generate the sequence of any values by using which one? Generator. Not only that, now you can also create customized iterators, right? For example, there is a list is there. Okay, there is a list. For example, there is one list. List 1 is there, which is having number of values. Okay, there is number of values are there in the list. So like this, you have some values in the list. Okay, you have some values in the list like this. Okay, these are number of values in the list. But see, you can read the content of the list using what? Index. You can read the content of the list using what? Slicing. You can read the content of the list using for loop. You can read the content of the list using iterator. But this iterator read in which direction? This iterator read in which direction? Forward direction. This iterator read data in which direction? Forward direction. So it means existing iterator provided by Python. The iterator provided by Python read values from this list or any sequence in which one? Forward direction. But I want to create my own iterator that should read the content in which direction? Backward direction. But is it Python provide any iterator to read in backward direction? No. So iterator provided by Python read only in which direction? Forward direction, but not in backward. But I want to read this data in which direction? Backward direction. Then what will I do? I'll create my own iterator. Okay, because generator function returns which one? Iterator. Getting on a generator function return which one? Iterator. Okay. So this is custom iterator I'm creating. What is the name of this one? Some B iterator or B generator or any function you can take. So some B iterator. What is the name of the function? B iterator. And this backward iterator and this function receives what here? This functions what it receive here? List. This function receive what here? List. List. It will receive what here? List. And from this list, it will return value in which direction? Forward or backward? Backward direction. Backward direction. It means when you're saying it is backward direction, you have to start the index at what? -1. You have to start the index at what here? -1. Index is -1. And index is while index is greater than or equal to minus length of which one? List. Minus length of the list. For example, if the length of this list is a 10, then -1 is greater than or equal to what? -10. Means it will start at -1, -2 like this. Okay, now then after that, what you are doing? You are saying yield. Now what you are trying to yield? List of which one? Index. But index starts at what here? -1. Then index is incremented or not? Yes. Where you are saying index equal to, what should I write? Index minus plus -1. Okay, so index, what is the value of index? -1. Minus of -1 becomes what? -2. Yes or no? Okay, now that will return. That will return which value? Next value. So are you reading in forward or backward? Backward direction. Then what will I do? I'll create iterator object. Some A equal to some B iterator. B iterator of which one? List 1. So you send this list 1 to which function? B iterate. But B iterator is which function? Generator function. And this generator function returns which object? Iterator object. Now A is which object? Generator iterator object. Using this object, I am reading the values from this list in which direction? Backward direction. So for value in what here? A, and print what is that? Value. Print value. You are trying to print the value, right? If you print it, is it this is forward or backward or back? So that is 99, 100, 101. So is it read all the values from this? For example, Python is also provided one iterator, right? This is predefined or user defined? Predefined. Iterator function is what? Predefined. B iterator function is what? User defined. Iterator function read in which direction? Forward. But B iterator function read in which direction? Backward. So this is also generator iterator, and this is also generator iterator. Okay. So here I'm saying for value in B, and I try to print value. I try to print value, but you are printing values. Okay. But in which direction? Forward direction. Now you can see 10 to 99. So customized iterators you can create it by using which functions? Generator functions. Okay. By using generator function. Okay. Yes. So you have to understand this, how to work with the generators and iterators. Okay, right now this is how you are working with the which function here? Generator function. So you can create your own iterators. Okay, you can create your own iterators. For example, so there's a function called alpha generator. Alpha generator. What is the alpha generator will do? Generate alphabets. You can give from where to where you want to generate it. Okay. So for x in range of 65 comma 91 yield. Okay, yield what is this character of x. So this will generate the alphabets from 65 to 99. Okay. If you want to read each alphabet, so a equal to alpha generate. If you want to read each value generated by this iterator, I'll say for loop for value in a, but this will generate all the alphabets. Okay, this will generate all the alphabets from 1 to, this will generate all the alphabets from A to Z, but this is alpha generator. See, any customized iterators you can create it by using generator function, and that will return generator iterator object. That will return generator iterator object. So that returns generator iterator object. Okay, right now this is how you are trying to write which function here? Generator function. Sometimes you can call a function inside a function. You can call a function inside a function, and that you can call it as that is called as which one? Function recursion. That is called as function recursion, or the same thing. You call it as recursive. Okay, that is called as a recursive functions. Function recursion or recursive functions. So there are different ways of, yeah, you can use next also. You can also use a next for reading next value from which one? Iterator. If you want to read a next value, suppose you don't want to read all the values. What do you do it? Just write value 1 equal to next of a. So this will return which value? First value. What is the first value generated here? A. Suppose you want to read a next value. Again say next of what is that? A. So this will return which value? Next value. So that is A, and one more is what? B. So you can also use next function to read only one value, because for loop will read all the values, but you want to read one values. Then you just send this generator iterator to which function? Next function. This is over. What example here? This is itself is example only, no? This is example or something else? Huh? We have seen already next in list. Yes or no? Iterator. How you iterate it? By calling which function? Next function. Okay. right? So you can also use the next year. Yeah, this will return each time one value. This will return each time one value, right? Right. So there is one more thing is there here, that is function recursion or recursive functions. See, there are so many problems. Lot of problems are solved by using which approach here? Recursion approach. There are a lot of problems which are solved by using which approach? Recursion. So what is a recursion here is calling the function itself. Calling the function itself is called which one? Function recursion. If you are calling the function itself, so that you can call it as which one? Function recursion. Okay, right? See, generally, yeah, there are some complex problems. Can we solve it by using which one? Recursion. Like most of the sorting algorithms, which makes it very simple. Sortings like merge sort, quick sort, heap sort. Okay, all these sortings will be applied by using which logic? Recursion logic. And not only that, when you are working with which one? Searching. It means most of the data structures, when you are working with which one? Data structures. Most of the data structures are implemented by using which one? Recursions only. So this makes it application development is more easy. But definition of recursion is very easy. What is function recursion? Is nothing but calling function itself. Calling function itself is called as what? Recursive function. Generally, a function is called by another function. But if the function is calling by itself, is called as which call? Recursive call. Generally, one function is called by another function. For example, there is a function 1 will be there. So there is a function 1. There is another function is there called function 2. Okay. So how many functions are there here? 2 functions. Assume that function 2 calls which function? Function 1. This is not recursion. Okay. Who calls the function 1? Function 2. Okay, no? But if function 1 is called by itself, function 1 is calling itself, right? If function 1 is calling itself, then this is called as which call? Recursive call. This is called as which call here? Recursive call. Recursive call. Recursion means calling itself. And recursion, calling function and called function both are same. Calling function and called function both are same. But generally, suppose function 2 is calling which function? Function 1. What is the calling function here? Function 2. What is the called function here? Function 1. But in this case, which one is calling the function 1? Function 1. Which one is a calling function? Function 1. Which one is a called function? Function 1. Now this you call it as which one? Recursion. Okay, recursion means repeating the same function again and again, right? So, but there are some complex problems which can be solved by using function recursion. Instead of using for loop, instead of using what? While loop. Generally, if you want to repeat the same statements again and again, you put inside what? A loop, right? So that can be a while loop or for loop. But there are certain problems you cannot solve it. I mean, solve it, but it becomes very complex. Okay. It becomes complex when you are using a while and what? For. But that makes it very simple if you are using which approach? Function recursion. Because function recursion is evaluated internally by using one data structure called stack. Okay, we'll see that how the evaluation is done and how it will work, right? How the evaluation is done and how it will work, we'll see that. But what is function recursion is, so what is function recursion is, what is function recursion? Okay, so calling function itself is called a, recursive function, a recursive function called, the same thing is called as function recursion. In function recursion, in function recursion, okay, calling function and called function both are same. Calling function and called function both are same. But generally calling function, in this case, for example, alpha generator is called by which function? Main. So main is which function? Calling function. Who's calling which function? Alpha generator function. So alpha generator is which function? Called function. But in recursion, calling function is called function. Both are same. Okay, it is just like iterating, means executing the same statements, executing same statements again and again, right? So that you can call it as function recursion. So complex problems can be solved, okay, solved in easy, okay, in easy manner, okay, in easy manner using which call here? Function recursion. Okay, so most of the data structures, function recursion. Okay, so example is like I said, like sortings and searchings and traversing techniques. Like when you work with the trees, you find some traversing like pre-order, okay, pre-order, post-order, like this. You find some traversing technique. Like we are working with the graphs, you also find some searching techniques. Even all these are implemented by using which call? Recursive function call. So there are some complex algorithms can be solved easily with the help of what? Function recursion. For example, see here, but function recursion is evaluated. Function recursion is evaluated using which data structure? Stack data structure. Okay, evaluation of function recursion is done by using one data structure. And what is the name of the data structure? Stack. What is the name of the data structure here? Stack, right? And stack follows what? Last in, first out. Stack follows last in, first out here. For example, see here, what I'm doing is I'm saying definition function one. Okay, then I'm trying to print one message. And what is the message I print here? Hello. What is the message I print here? Hello. Hello is a message. And after printing the message hello, again I'm calling which one? Function one. This is called as which call? Okay, this is called as which call? Recursive call. This is called as a recursive call. Now, so this is the main function calling which function now? Function one. And main is called by Python virtual machine. So main function is called first. And this main function is calling which function? Function one. And function one is printing a message. What is the message it is printing? Hello. After printing a message hello, what it is calling again? Function one. Again, it will print a message called which one? Hello. And again, it is calling the function one. Again, it will print the message called which one? Hello. But how many times this repetition is done? How many times it is repetition is done? Not infinite time. But what is the maximum recursive depth is 1000. What is the maximum recursive depth is what? 1000. If you don't give any stop, if you don't give any stop, what will happen? It will try to repeat this recursion how many times? 1,000 times. 1,000 times. And you can set a recursive depth also. You can set a recursive depth also. Now suppose I'm trying to execute this. When I execute this, now it's keep on displaying it, right? But how many times it will display it? Okay. So is it 1,000 times? Okay. So recursion error. It is given which error? Recursion error. Maximum recursion depth exceeded while pickling an object. Means while executing this object, maximum recursion depth is what here? Exceeded. But what is the maximum? What is the maximum depth of the recursion? 1,000. You can see that. You can see that if you don't give the stop condition, if you don't give the stop condition, you should not think that it will execute infinite times. You should not think that it will execute what? Infinite times. It will not execute infinite times, but it will try to execute how many times? 1,000 times. But can you set the can you set the can you set the can you set the recursive depth? Yes. By using sys module, there is a sys module is there. Within the sys module, you have a function called set recursion depth. Okay. So there is one function is there. Okay, sys module is used to communicate with what? Python virtual machine. Sys module is used to communicate with the Python virtual machine. Now you are telling the Python virtual machine, okay, set a depth of the recursion. You are telling the Python virtual machine, okay, set a depth of the recursion. So there is a setter. So there is a setter function here. You can see set a recursion limit. What is the name of this function? Set recursion limit. Now set the maximum depth of the Python interpreter stack to limit. The limit prevents the infinite recursion from causing an overflow of C stack and crashing which one? Python. Okay. So if it is infinite, what will happen? There is a chance of crashing which one? Program. Because of that, maximum depth is set by using which one? Set recursion limit. Okay. So there is a function provided by which module? Sys module. There is a function provided by sys module. But what is a default? What is the default depth of the recursion? 1,000. So if you don't give the condition, it will repeat 1,000 times. So default recursion set by Python virtual machine. Set by Python virtual machine is how much here? 1,000. But this can be changed. This can be changed by using which module? Sys module, right? So what I'm doing in sys module, I'm just writing import which module? Sys mod. Suppose if I don't call this, now import which module? Sys module. And within sys module, I'm saying sys dot set what is the function name? Recursion limit. Set recursion limit. I just use a function called set recursion limit, but I give the recursion limit as what? 5. Then how many times it will print the message hello? How many times it is displayed the message hello? 5. I said 5, right? So after that, it is given one message. What is the message? Maximum recursion depth what here exceeded while pickling which one? Object. You can define the maximum number of recursion call. But if I'm saying 10, so what is the maximum here? 10, right? So we can define the recursion depth by using which one? A recursion, set recursion limit. When you say set recursion limit, how many times it is? 100 times. Once it is exceed 100 times, then immediately you'll get which error? Recursion error. Okay, immediately you'll get which error? Recursion error. Generally, you don't do the recursion without giving condition. Okay, if you don't give the condition, what will happen? It is just like infinite loop or not? Yes, infinite loop. Infinite means you are saying call function one, call function one, call function one. How many times it will call the function one? How many times it will call the function one? Once it reaches to what? Maximum depth of the recursion. What is the default maximum depth of the recursion? 1000. But you can also define the depth of the recursion. But generally you don't do this, because always you write a while loop. You'll say while followed by what? Condition. And recursion also executed based on which one? Condition. Recursion also executed based on some condition. If you don't give the condition, then it will execute this until it reaches to maximum limit. It will execute it until it reaches to what? Maximum limit. But default maximum limit is 1000. But once it exceeds the maximum limit, then you'll get recursion error. Once it exceeds the maximum limit, then you'll get which error? Recursion error. But in order to work with the recursion, what you required is, in order to work with the recursion, you required 3 statements you required. To work with the recursion, you required 3 statements. Like to work with the looping statement, you required how many statements? 3 statements. To work with the while, you required how many statements? 3 statements. Like initialization, condition, and one more is what? Updation. In the same way, to work with the recursion also, okay, to work with the recursion also, you required how many statements? 3 statements. To work with the recursion also, you required 3 statements. That is initialization, condition, and one more is a updation. Okay, yes. So recursion required how many statements? 3 statements. One is initialization statement. Okay, initial statement or initialization statement. And second one is which one? Condition. And third one is which statement? Update statement. Okay, initialization statement. So initialization statement defines, okay, define initial value of which one? Initial value of which one? Condition. And condition is a Boolean expression. Condition is what here? Boolean expression. Condition. What is a condition here? Boolean expression which define how many times a recursion, how many times recursion has to be repeated. How many times a recursion has to be repeated, so that you define it using which one? Condition. And next one is which statement? Update statement. Update statement which update what here? Condition. The update statement updates what here? Condition. So there are number of statements out there. Initialization statement, okay, initialization statement, condition, and one more is what? Updation. Initialization statement define the initial value of condition, and condition is a Boolean expression which define how many times the recursion has to be repeated. Update statement which update what here? Condition. So these are three statements are required in order to work with what? Recursion. If you don't give these three statements, what will happen? The recursion will repeat how many times? Maximum number of times. Recursion is repeated how many times? Maximum number of times. To avoid that, you'll try to write how many statements? Three statements, right? Just to see here how this is. For example, I want to generate 1 to 10 numbers. Basic example, or 1 to 5. I want to generate 1 to 5 numbers. 1 to 5 numbers, or I want to generate n numbers. Okay. So I'll say function. So print. What is the name of the function? Print number. What is the name of the function? Print number. Is a function we should print the numbers from 1 to 1 to number 1 to n or 0 to n. Okay, n. So I'm giving which value here? N value. Suppose if the n value is 5, it should generate 0, 1, 2, 3, 4 and 5. If n value is 10, it should generate from 0 to 10. Okay, now then what I'm doing here? Print number will generate print number receive which value? N value. After receiving n value, you are checking one condition. What is the condition you are checking is if n is greater than what? If n is greater than or equal to what? 0. If n is greater than 0, okay, I'll say if n is greater than 0, then I'm saying print number n minus 1. Print number n minus 1 and then I print which value I'm printing? Number. Which value I'm printing here? Number. What is the value of number? N. What is the value of number here? N. Okay, now suppose if the value of n is 5, it should generate 0, 1, 2, 3, 4, 5. Okay, now this call is called which call? A recursive. This is called as recursive call. Means is it function is calling by itself or not? Yes. Suppose I want to print print number. I want to print how many numbers? 4 numbers. That is 0, 1, 2, 3, 4. 5 numbers it will generate. Okay. Yes. But how it will generate? Just to see here. If you run this, now you can see 0, 1, 2, 3, 4. Okay. So 4 values are generated or not? Yes. So what is initialization? What is the initially value of n? 4. And what is the condition? N is greater than 0. Repeat this recursion. How many times? Infinite times or until given condition? Until given condition. This is a condition, right? Repeat this recursion. This is recursion, right? Repeat this recursion until n is greater than 0. If n is less than 0, is it this recursion is done or not done? Not done. So initialization is there, condition is there, and then updation. Updation means n minus 1. What is the value of n? 4. 4 minus 1 is what? 3. 3 is greater than 0? Yes. Then 3 minus 1 is what? 2. 2 is greater than 0? Yes. Then 2 minus 1 is 1. 1 is greater than 0? Yes. Okay, then 1 minus 1 is 0. 0 is greater than 0? No. So what will happen? It will print which value? N value. So I said recursion is evaluated. This recursion is evaluated by using one data structure. This recursion is evaluated using one data structure. And what is that data structure it uses? Stack. But how it is printed 0, 1, 2, 3, 4. You should know this process, right? How it is printed all these values. How it is printed all these values, you should aware of it, right? Then we'll see how to work with this. But how the evaluation is done? But this, so this evaluation might take some time, right? So how this recursion work internally? Okay, we'll see with some application, but not today because this will take some time. Explanation will take some time. Okay, tomorrow I'll explain how this recursion will work. Okay, how this recursion will work, how it is printed 0 1 2 3 4, right? We'll see what is a stack frame and what exactly recursion is, right? Not today, but tomorrow we'll discuss this. Okay, so today we'll stop it here and tomorrow we'll continue. Thank you. Thank you. We'll see tomorrow, right? Yeah, sometimes they may ask to flow of execution of recursion, that I'll explain tomorrow.